Okay, so Leetcode practice time. So in this video there are two goals. The first goal is to see how we are going to solve this problem, and then we are going to do some coding here. And the second goal is to see how we should behave properly in the real interview. So let's get started. So remember, the first step in the real interview is always first try to understand the question. If there is anything unclear, please bring up the question to the interviewer to clarify, and also at the same time think about some edge cases. So let's read through this problem. So regular expression matching, given an input string s and a pattern p, so implement regular expression matching with support for dot and a star, where dot matches any single character and the star matches 0 or more of the preceding element. So the matching should cover the entire input string, not partial. So let's take a look at the example 1. S equal to A, P equal to A, then return false. Yeah, S equal to A, P is equal to A star, return true, because we can have any number of the preceding A's. Okay, similar for example 3, 4, and 5. So let's see some constraints. So the lengths of S and P are within 0 to so S is within 0 to 20 and P is within 0 to 30, and S contains only the lowercase English letters, P contains only the lowercase English letters, and dot and star. And it's guaranteed for each appearance of the character star there will be a previous valid character to match. Yeah, so I was worried about what if there is some invalid input. So for example, if it is just star, or maybe C star star, those are invalid input, but seems like there's some constraints saying that this kind of input won't appear, so we don't need to worry about those kinds of edge cases. So other than that, I think we should be good to go to get into the next step. So the next step in the interview is to try to find the solution. So let's see how to solve this problem. So my first idea is to use some brute force search to solve this problem. So the brute force search is we write a DFS function, and so S start with 0 and P start with 0, and we try to enumerate all the possibilities preceding the index for S and preceding the index for P in each time, and then finally we find if there's any movement that can successfully arrive the end of S and P, and also each step is a good match. So that would be workable, but it's not the best regarding the runtime. So let's see if there's any better solution. So I think this seems more like a DP question to me. So so for the DP, I would say, let's say DP I and J. So I is I represents index of P, index of S, and J represents the index of P. So for the DP array, the formula it would be if so let's say if so if S if Si plus 1 is not equal to star, that's just regular matching, then dpij would be equal to dp I plus 1 and j plus 1. Otherwise and by the way, dpij means starting from index I and starting from index I of within S and starting from index j within P, whether it is possible for us to have a good match. And also, otherwise, if Si plus 1 is equal to a star, then we have two options. The first option is okay, so if first of all, if as I plus 1 is not equal to a star, it depends on this dp I plus 1 and j plus 1, and it also depends on the Si and pj. So if the current character matches and the follow-up things match, then so it really depends on the current character comparison result and also the follow-up result. So if it is not, if the next character for S is not a star, if it is not a star, then it depends on this condition. But what if it is a star? So if it is a star, then it really depends on. So we have two ways to do it. So the first way is to, let's take an example. Let's say we have the A star. So it could match like an empty string, and it could match like a couple different A's. So we have two ways to proceed. The first way is we just don't use this A star to match anything. Then it will be just solely depend on so it will be solely depend on the I and j plus 2. And otherwise, we could use it to match a couple of the same characters at this moment. So it would depend on Si equal to Pj, and I would say it is I plus 1 and then j. So because we just, for example, the same example like this, when j is here and then I is here, I pointing to the same A, to the A, j pointing to the A in the pattern. So I'm just explaining the second way. So we could try to use this to match the same character and move I to the next one, but we don't move j because we could use the current pattern to match more of the same characters, which is more A's in this case. So that's essentially how we represent the DP, how we calculate the DP formula. So since to calculate the DP matrix, it requires let's say the length of S is n, then the length of P is m, then the total runtime is going to be O and m. So that's essentially how we are going to solve this problem. And after we find the solution and we do certain runtime space analysis, then it's time to do some coding work. So regarding coding, we care about the correctness, readability, and also the speed. So let's take a shot for the coding part. So first of all, we need to define the DP array. So we couldn't define a Boolean array because we don't really know the corresponding DP element has been calculated or not. So instead we could use, so for battery, we could use like integer array, but I would say for battery readability we could define a enum array. So let's say the enum is, let's call it match. So we would have two things. The first one is true, and the second one is false. Alright, so that's the enum definition, and at the first place we are going to say, let's say the match array, let's call dp is equal to new match s.length and p.length, and we are going to, let's define a function, let's call it is match, passing the s, the p, and this 0 means the index of s, and this 0 means index of p, and we pass the dp array into it. So we are going to define helper function, which has a reload of the function we previously defined. So we have s, p, let's say int s idx, and this is int p idx, and we have the match array, which is dp. So first of all, this is a recursive function. For a recursive function, usually you need to define the exit for it. So let's see what is the exit. So if the dp so should we return a Boolean or should we return a match, like a match enum? So it wouldn't matter, so let's just return a Boolean. So if dp if dp s idx and the p idx is not equal to a non-pointer, then we just return dp s idx and the p idx. So it's just idx, not the e. Yep. So it's equal to true. Otherwise, we would say, otherwise, if it is equal to none, then we need to do some regular computation. So I would say if so first of all, if the p idx is equal to the p dot length, then we are going to say, alright, so dp as idx alright, so we just say Boolean as is, let's say match as equal to the false. So match would be equal to s dot length to be equal to s idx. Otherwise, it will be something like we need to do the comparison based on the formula. We need to do the comparison about the current character we are looking at. So there are two different branches. The first one is to see whether it is whether the follow-up character is a star or not. So I would say, first of all, we need to see whether the current character really matches. So current car match, say, is equal to, so if s is the index of s is out of the range, then of course it's false. So it would be s idx is smaller than s dot length, and so s and so either way, so if the s dot, so if p dot car at p idx is equal to a dot, or if it is not a dot, then we need to make sure that the two things matches, or the p dot car at p idx is equal to s dot car at s idx. So for this condition, it means if the current character from the pattern is a dot, then it can pretty much match everything, or the current character matches the current in the pattern matches the current character in the string. And anyway, we need to make sure that the s is within the range. So for the next thing, we need to see whether the next character in the pattern is a star or not. So if p idx is smaller than p dot length minus 1, and p dot car at p idx plus 1 is equal to a star. So if it's equal to a star, then that's this part of the formula. Otherwise, if it is not a star, we pretty much just need to have match as equal to car and car match, and is match as p s idx plus 1 p idx plus 1 and the dp. So if sorry, this should be within this else branch, which means it's not, the next character is not a star. If it is a star, then we have two ways to do it. Is equal to, it should be equal to so the first one is to see is this part, which is match as p as just stay the same, as idx stays the same, and p idx plus 2. Or there is another way, which means we need to make sure that the current character match, and we need to make sure that is match, which is as p as idx plus 1, and then p idx, and this is a dp. We need to pass in the dp. Okay, so that's pretty much it about different branches, and we need to set the dp as idx p idx to be equal to the match, and it's not equal to, so it's not, it's something like if it is match, then it's match dot true. Otherwise, it is match dot false. And finally, we are going to return the match. So that's pretty much it about the inter code. Okay, so I need to say this is match dot true. Sure. And the next step, after we are done with coding, is not everything is, it's not like everything is done. We still need to do some testing. So I would say the first step is to go through a sample test case, explain how this piece of it is going to work, and then this is about doing some sanity check on the logic. And after that, we will come up with different test cases to try to have good enough test coverage. So let's take a look at the first example. Let's say the AA and A star. So first of all, we have the a new match as lens and P lens. So I'm thinking if we need to have as the lens, is it really, so if the lens, I think the better way is, the safer way is we have as the lens plus 1 or P the lens plus 1. But I'm not sure. So is it really, it doesn't matter much about the space, but I'm thinking if it is really required at this moment. So I think sometimes we may arrive at the place that the index is actually as lens or P lens. It could be possible. Okay, so let's go through this test case. It's AA and A star. At the very beginning, we call so let's say we have the AA and A star. So currently we have the S index as here and P index as here, and we are going to say match is false. So we come into this else branch, we see that the car is a good match. Then there are two ways. So the first, because there is the star that come afterwards, there are two ways. The first way is we just move the P towards the end, and for the next call, this is going to be false, which means we are going to have dp 0 and 2 as equal to a false. And the other way is we just keep the P, not move it, and then we move the S. So we move the S, the next step, we still have two ways. The first way is we move the P. So if we move the P here, and when we call the recursive function, we should also have the P12 as false as well. And also, there's another way. We try to move our S, here, and when we call this function, like the recursively call this is match function, we have another two ways. The first way is to move the P to the right by 2. Then we will have dp 2 as equal to true. So that's essentially how it will work. So finally, I think we have 2 as true, and when we return, we are going to like step by step. When the stack call stack returns, we will have the isMatch as P00 dp to return true. I think that should be yes. So let's give it a shot by doing some run on this runnable platform. So I think there's some typo here. So so it's saying that we need to have alright, so I think we do need an extra closing parenthesis here. Yeah, so okay, so it's as idx, not okay. Alright, so it's accepted. Let's do some other testing. If it is A star, what will happen? It's okay, and if it is, let's say, just give something like this, should return true as well. Alright, so it seems like things are working well. Let's okay, so everything looks good now. I would say regarding the test case setup, definitely include something like example 1, which doesn't contain any regular expression, and also include something like example 2 contains like A star, and also example 3 is also a good one. So say if we include all those 3 task cases, it should be mostly good because we should have good enough test coverage about different branches. So that's it for this coding question. So if you have any question about the solution itself or about anything, feel free to leave some comments below. I hope you find this video a bit helpful. If you find it good, please help subscribe to this channel, and I'll see you next time. Thanks for watching.